Hello, everybody. We are working on our Chapter 8 exercises tonight. We are going to start with exercise number 1, which is called 9ints.java. It says, write an application that stores 9 integers in an array, display the integers from first to last, then display the integers from last to first, and save it as 9ints.java. Right, I'm going to go ahead and bring up my coding environment here, which I did not preemptively do. That's kind of interesting. Normally I have it up and running. Let's make sure we got the right class and semester. We sure do. And let's get our environment launched here. All right, you can see we have all our code from last week still up in the interface here. I'm going to go ahead and close all these. And yes, I do know there's a close all command in the menu, but sometimes it takes a lot of mouse movement to go all the way up there. I'm going to begin by actually creating a new project here. So we have a new folder to work within. So I'm going to just come up here and say new Java project. And let's go ahead and name this very logically Chapter 8. All right, and you can just go ahead and straight away and click Finish. Inside the Chapter 8 folder, and yes, I'm going to expand it. I'm going to right click and create a new class file. And I'm leaving my package declaration blank. And this one's going to be called 9ints. And yes, we do want a public static void main here. And I assume this is big enough for you guys to see. I will zoom in just a couple of clicks here just to kind of get us going. Not doing anything particularly fancy here. We're not being asked to prompt the user, so I don't think we need a scanner or anything like that. Really, we're just going to build an array. We're going to look at a couple different ways to do it, and then we're going to output that array a couple of different ways, and then I'll show you which ways are better than the others. First of all, we need to create the array that's going to hold the values. And so in my mind, I think it makes a whole lot of sense to create a declaration for it first. So why don't we go ahead and say int, and then we can put in our square brackets to show that it's an array. So it'll be an array of numbers, basically. And we could just declare it just like that. This is empty. It doesn't have any size or shape, right? All we have is basically the declaration. Next, we could start to populate values. And one approach, and this is where the book, I believe, starts, is they begin by going, okay, in position 0, the first position, let's put in the number 10. In the second position, let's put in number, I don't know, last time I used 15. And then you can just continue this process until you get all the 9 values that you need. Of course, you would count up to the number 8 here, right? Because we're starting with 0. And then you would come up basically with your list of the values and how they're stored. Okay, and that's fine. And you can do this at any point in time. If you want to force something into array position, you just call the variable by name, which position you want to put it into, and throw something in. Not a big deal. The only difference between this and declaring a regular variable is the fact that we're selecting which position it's going into in the memory structure. Okay. Now, this approach works just fine, and many of you may have built your arrays just like this. And you know what? Absolutely fine, no problem at all. However, so here's the however. It's not how I'm going to do it. In fact, most programmers would not build an array from scratch this way because, frankly, 9 numbers, not a big deal. 1,000 numbers, big deal. You don't want to type 1,000 lines of code to do this. Very, very cumbersome. There are much more efficient ways to do it. So one way that programmers will often populate an array all at once is to use this fun little syntax, which is to still use the name to declare it, but then feed into it inside of a set of curly brackets. So I'm going to create the opening and closing ones right away, a series of numbers separated by commas. And so I'm just going to type in 9 numbers here. And I'm trying to be clever here because there's actually a little bit of a method to my madness here. I'm kind of putting these in sequentially on purpose because if you guys remember, they want us to print them out in order and then reverse order. And if I make them somewhat sequential, it's really easy to see both. So I got 1, 2, 3, 4, 5, 6, 7, 8. I need 2 more values here. And there, folks, you have one declaration that will create and populate the array all in one fell swoop. And that, I think you will agree, is a lot more efficient than doing each one separately. What position do these drop into? The corresponding position in this list. So in other words, 10 will go into position 0, 15 will go into position 1, 24 will go into position 2, 36 into 3, 4, 5, 6, 7, and 8. The 8th position by index value, remember, is the 9th position in the array. And a way to kind of reinforce that, this is where that spreadsheet thing I think is handy, because that number offset, right? And so you could use a thing like this. If you have a hard time visualizing it, you can draw this out on paper. You can use a spreadsheet or whatever. And I think, real frankly, it helps. And maybe you don't feel that way, but I've seen it help people who are really confused with the concept of it. And in fact, the smaller you make it, the more convenient it becomes to look at. And I think this is kind of cool. I mean, when you look at it like that, if you have a visual of what you're doing, it helps to understand it. Maybe you don't feel that way, but I certainly do. And there's no embarrassment that, if that's what you need to do in order to visualize it and get it, then do that. Remember, going back to my story now, I was taught this concept, and I forget what language I even learned it in first. I don't know if it was like Pascal or COBOL or whatever it was, probably C, honestly. But I didn't understand what I was doing. And I had a sit down with the instructor, and then one other student had the same problem. And then the other student got it before I did, and then they were both talking to me. But what they ended up doing is basically drawing a graphic like that one that I just did for you in the spreadsheet. And then I was like, oh, all right. Okay, never mind. It makes sense. That's kind of how I was with it, but it took that in order to make it happen for me. And frankly, it took years beyond that before I really saw the power of arrays and what they're really useful for.
So Ty, when you do it that way, are you able to later in the program go in and add a position like 10, 11, 12, or does it define it here?
No, it does not limit it here. Absolutely not. You can actually append to the array. There are ways to increase the size of the array and decrease the size of the array. So that's a really good question. Yes, you can dynamically change it. It's a very good question. All right, let's move on to the display part of this. So now, to display this, you can actually do something very simple, right? So for many of you, you might have done this, and I'm just speculating here, but I think it's a pretty safe speculation that you do a system out print line or print, whichever, it doesn't matter really, and then you can just directly call in the variable name and the position number. So if I want to output what's in position 0, well, there we go. And in fact, why don't I just go ahead and run this, and I'll just show you really quickly that this works. All right, so let's run that. And that will output the 10. And remember, it's going to position 0, the first position, and it's pulling back the number 10 and putting it on the screen. And I suppose if you wanted to output everything in order, one thing you could do is you could just come in here and just start doing this, right? And just changing these values. You could go to 1 and 2, etc. And I'm not going to follow through that whole process, but you get the idea. You can count all the way up, and yes, it will give you the right output. And then if I wanted to do them backwards, I just list those all in reverse orders, and it'll do it. But this, even though it works, once again, highly inefficient, and no real programmer worth his weight would really do it that way, because it's just inefficient. It's good for like a quick little fix, but what if you're dealing with a list or an array of 1,000 numbers? Completely different. You don't want to type 1,000 lines of code. And so what you do instead is you come up with clever ways to do it more efficiently. And so the clever way would be what? What would be a way to output the contents of a loop? See, I just gave away the answer. The output of an array. Okay, so I gave the
Would it
answer
be a
right.
for loop?
Yes, a loop is a perfect mechanism. And frankly, folks, you can use either a while loop or a for loop. But what you learn is you kind of get more experience with programming is when a loop is typically designed to run a specified number of times, most programmers will usually default to a for loop. So Laren, you're spot on with that part of it. So let's go ahead and build one. All right. So here's the first one. For int I equals 0. Why do I start with 0? Because our array index starts with 0. Makes perfect sense. So I will go from I, starting at 0, up to the length. And I want you to see what I'm doing here. So here's where some of these methods come back, where we are actually going to take the length of numbers. And this is a built-in method, once again, that operates on arrays. And it will pull back however long that is. Now, this will return, if we have 9 values in here, it will return the number 9. But our last index position is 8, right? And so therefore, just the less than sign rather than less than or equal to, which would include that, position that's not there. Any for loop has to have some sort of increment or decrement or change. And so we're going to put I++. We're just going to increment it each time, count up from 0 to however far we need to go, which in this case is the length of the structure, but one less than it. We never reach it. Now we'll throw in our curly brackets. And you know what? This is pretty easy. In fact, we can do it all on one line. We don't even need multiple lines of output. And so this is what I did. I just did a simple print statement that'll print out the number. I think I got 2 spaces in between. So it'll print it out kind of like this. The commas will be replaced by spaces. Heck, if I wanted to make it look just like the list, I could put a comma in there instead, but I chose to put spaces in. And then that's all it takes, folks. So let's go ahead and just run this really quick, and you'll see that this will display the stuff in order. It'll start with the 0 position, and then go to 1, 2, 3, 4, 5, 6, 7, 8, never reach the 9th position, which is index value 8, because of numbers.length right here, and give us our output. So let's run this and take a look at the results. And you can see all the numbers put back on the screen in order. Piece of cake, really. Okay. But now we're also asked to do it in reverse order. Well, the first thing I'm going to do is I'm just going to do a really quick system.out.print line here to give me a blank line in my code and move us down to the next line. And then we're going to run another for loop to go the other direction. All right. So this one will look really similar, a little bit of a logic change though. So watch how this one is structured. Once again, we're going to have a counter variable. We'll use I again, it's okay, since we're already done with its usage up above. And here, instead of starting at 0, well, we have to do something else. We have to start at the back end of the array, which will be whatever the length of the array is, minus 1, because we have to consider the index value. So if this is 0, 1, 2, 3, 4, 5, 6, 7, position 8, the length of the array is 9. 9 minus 1 gives us 8 and gives us the right starting point. So our syntax here will be numbers.length minus 1. The beauty of this statement is if I decide to come back here and add 20 more numbers, it still works, right? Because it will dynamically adjust to the size of the array. And that's important. Yes, I could have hard-coded a number here, and I could have hard-coded the number 8, and it would work just fine. But it's much smarter to do it dynamically. In other words, allow it to adjust to whatever the size of the array is. In this case, we're going to start at 8 and count down to 0. So we're going to go from I which is going to start at 8, greater than or equal to 0. So when we reach 0, position 0, we stop. That's the last one. And instead of incrementing the counter, we are going to decrement the counter. We're going to decrease it. So instead of I plus plus, we do I minus minus. And now output-wise, output's exactly the same. There's no difference there. We have the same output statement. And then if you wanted to add another print line there, you don't really need to. That will do it for the countdown. Let's go ahead and save this. Control S to save, and then a run. So now you can see the numbers in both orders, and we did this manually. I will mention, okay, so this is important to mention. There are methods that are pre-created that do this automatically. You don't have to write the code, but the real lesson here was create the array, either the long way or the short way, and output it, either the long way or the short way. But you will see very commonly, and why do I do loops and arrays together? Because they often operate together. So it's very common if you have an array structure that you use a loop mechanism to traverse the structure to either write information to it or read information or change it, right? It's just a very helpful combination. Once again, we're using a very small list of numbers. Not a big deal to do it manually, but imagine that list of numbers was 1,000 numbers long. Completely different story. You do not want to write 1,000 lines of code when you can write a couple and do the exact same work. It's just a matter of being more clever. That's the power of looping. And then combine looping on top of arrays, you have a really powerful combination, folks. All right, any questions on this one? Everybody okay on this? All right, let's move on to the next exercise now. I'm going to jump back over to the textbook and just kind of read the description here. Our next exercise is exercise number 2. So exercise
You
number
also
2
need to
says,
reshare your screen time.
thank you so much, because now my silly face is getting recorded on the screen and you guys don't want that. All right, so here we go. The second one is called distance from average. Allow a user to enter any number of double values up to 15. The user should enter a series of 9s to quit entering numbers, display an error message if the user quits without entering any numbers, otherwise display each entered value and its distance from the average of the numbers you've collected, basically, and save it as listed. So why don't we begin that one? This one, as you can anticipate, is going to have a little bit more code than what we just saw, but we have clues on how to complete it, right? So like the password exercise that we were working on last week, that will give us like the loop of when to quit, right? That approach. We know we need a scanner this time around because we are getting input from the user. We're working with an array of doubles instead of integers, and we're given some other parameters here, like we only can go up to 15 values. Okay, so that's another piece to this. So let's jump back over to Eclipse and create a new program here. So I'm going to right click, create a new class file. And this one is called distance from average. And yes, we want a public static void name. So here's the beginning stub for our program. I know I need the scanner, so that's going to be the first thing I take care of here. So let's just type in the scanner. We'll do our control space to add the library automatically. We will call this input or whatever you choose to call it. And that will be a new scanner system dot in. And let's close out our statement. The next thing we have to do is make the array, right? And we were told explicitly, in fact, let's just read that book. Allow a user to enter any number of double values up to 15, any number. So they can enter 0 or 1 value, or they can enter up to 15 different values. So then the question becomes, how big do I make the array? Okay, so here we're actually being asked to predefine the size of the array And so I'm going to begin first by recognizing they asked me to make a double array. So it's an array of double numbers, floating point numbers, basically. Yes, let's just call it numbers, easy enough. And then because of this, we are going to use a different syntax here. We're actually using constructor syntax for the array. And here inside the square brackets, we're going to declare the number of positions, not the highest index value, but the total number of positions. And I want you to understand that it's going to go from 0 to 14 index values, but that's a total of 15 positions. All right. And so here, in this case, we are presetting the size of the array, whether we use all the positions or not. Another thing that I'm completely aware of is if I'm going to be calculating an average, that means I'm going to be adding all the numbers together, and then I'm going to do some math and come up with whatever the average of those numbers is. And I need some variables to store that stuff. So smart move here is if I'm going to be totaling floating point numbers, it's a smart idea to have a variable pre-created to hold all the total before I do my division and then come up with the average. But you know what? I probably, at least from a programming standpoint, makes sense to also store the average. And you guys notice that I'm presetting both of these to 0, just in case the person does not enter anything and we have problems. We want to have some sort of a number in there to begin with. Another thing that we want to think about as well is how about a variable to hold the entry that the user just typed at the keyboard. And yes, I could pre-enter a value, but that's going to be dynamically grabbed. And if they don't enter anything, no harm done. So I'm not presetting that one. Let's see. Another thing that I'm thinking about here is I might need a way to refer to the number that I'm currently working with in order to work with the math. In other words, I'm going to keep track of the variables, or excuse me, the numbers that I'm putting into the array. And every time I put a number in, I may as well count how many I have. So for example, I'm going to keep prompting the user, enter a floating point number. Okay, type one in. Enter another floating point number, type one in. And every time I do that action, I may as well keep a count, because that count will then come in handy for calculating the average, because I was counting all along and the number will be set. Now, I could create a double and call it count, and probably most typically I would do that, but in this case I'm going to use a single letter to do it, because for me it makes for cleaner code down below. If you want to put in count or letter C, if that's better for you, do it. All right, so now that we have these constructs in place, we now begin with prompting our user. So we'll start with just a simple system.out.println, and we'll say something like enter a numeric value, or I don't know how many nines. The problem that they have here is that the number they want us to use to quit, is a number. And so I'm going to put in a series of 4 nines. I think they did 5. So that's one number that a user can't enter, unfortunately, to quit. All right. And then maybe a little prompt indicator just like that. Of course, we're going to grab that input and we're going to store it in the entry variable. And we're just going to say input dot next double. This is a double we're typing in now. And it doesn't matter if they type in a floating point number or not. Nope, not at all. You type in an integer, it'll treat it, it'll grab it as a double, by the way. So that's our initial prompt. Now we get to the point where now we have to figure out if we're going to keep running the program or not, because there is the potential that right off the bat, the user enters the 4 nines and we're done. Okay, that's not good. So we better contend with that. If they don't enter the 4 nines and they enter a value that's valid, then we can run our code and do the next steps. And because the next step is basically entering series of numbers into the array, it will be repetitive and a loop. The better structure in this situation is actually the while loop. And this is the same thing that we saw with the password program, is that we can run this loop as long as the entry does not equal, that's what the exclamation is, not equal 999. And as long as we don't exceed the length of the array. Now, X is going to be my counter. And so if that exceeds the length of my array, well, that's going to stop it too. So we have the beginning of our loop. Now, for every time we go through that loop, we are going to take the entry from the user and assign it to the array position. The first array position we're going to assign it to is position 0. X starts out at 0. Perfect. Okay. So we're going to just say numbers, square bracket X. X will dynamically change every time through the loop. We will take the user's entry and store it in that position. Then, since we're keeping track to do an average, we're going to add to our total field. In fact, maybe the smart way to do it here is just to do a plus equals. And then we're just going to take that same, whatever is in that position X, and add it to the total for calculating. We're using the X as a counter. At this point, we're going to increment, right? So we've already grabbed the value. Now we can change the value of X to the next value. Then we need to kind of think about the fact that how do we get the user to enter the next value? Well, we have to prompt them again. So the one thing that you might do is like, okay, well, we'll just put this in there and prompt again. But there is a scenario, and that is true, we do need to put this in, that if X has reached beyond the length of the array, we actually don't want to do it. So we do want to do that only if we're within the range of the array. So the easy way to do that is to compare X to the length of the array. So as long as we're shorter than the length of the array, then we can keep prompting. And so here we would add a copy of this prompt. All right, but only if we have the capacity to do it, right? So if this scenario catches to prompt again, if we're less than the length of the array, it will prompt again. If not, not only will this not prompt, but the loop will end as well because it has the same criteria, right? And all along the user can type 999 to exit. Okay, so this little thing has captured all the values we need to put into our array structure. I'll get rid of that extra line there. Right, next thing we need to do is think about the scenario. What if the user didn't type anything? What if they just they got the prompt and they pressed enter? It's nothing, right? Well, we have to accommodate for that too. We can't do it inside of the loop though. So if they ended up not typing a darn thing, so if X equals 0, just like when it started out, then we should probably give them a message, and you can give them a message sort of to the effect of something like this. This is what I put in last time I did this. I just did a simple system out print. Right, so very simple message. Just kind of tells them how it is. You did not enter any numbers, calculations cannot be performed, maybe even goodbye, or try again, or something like that. But what if, and I'm looking at my curly brackets here, are these matched up correctly? Or am I actually missing one here? I think I'm missing. All right, I am missing one here at the end. So this curly bracket, I think matches, yeah, it matches the main method. Okay, so we are missing a curly bracket here, folks. And what I needed to do is do this. to close that if statement. Now I can do an else. So what if, for example, they did enter something and now we can do all the math that would give us the right answers. So the first thing you should know is that an average, and the variable we created for it, is calculated by taking the total that we've, the sum of all the numbers, and divide by the total number of numbers that we have. Then we can do a simple system out print line here, and this one I'm just going to paste in, saying something to this effect. And it said you entered X number of numbers, and their average is average. But for each one of the numbers, we're supposed to display how far each number in the array is from the average that we've calculated. And that's going to be something that we have to do, unfortunately, in a loop. And that's not unfortunate, I guess, but most efficiently, I guess is the best way to say it, in a loop. So in this case, we are going to run another for loop here, and we are going to start with a counter, and let's just use I this time, and 0 to start with. And we are going to go from I up to X. So in other words, we're going to start at 0 and we're going to count up to however many the user entered, and then increment 1 each time through the loop. And then perform these functions, which is basically just an output at this point. And I'm going to just paste in my statement here so you guys can see it, but it's just a simple system out that actually includes the number that we're currently looking at. So it'll look at the number in the array. It'll then take that number, subtract the average from it, and that will give us a distance relative to it. So let's say I have numbers from 1 to 10, and I calculate an average of 5, and then the number 6 would be 6 minus 5. 6 is 1 away from the average, if you guys see what I mean. So the distance from the average. If it's less than the number, it will be either positive or negative, or if it's more than the number, which will indicate basically direction. So you may get a negative number here, or you may get a positive number. It really depends on where you sit relative to that number in the number line. So some people will think about this or overthink it and say, well, Ty, don't we have to do an absolute value here? And I'm like, well, I suppose if you really want to do that, you could, but a positive or negative value is absolutely acceptable in my mind, because it indicates not only distance, but direction as well. All right, let's go ahead and save this and try to run it. This is kind of an interesting one here in terms of how it operates. So let's go ahead and get it to go. Oh, and it says I got errors. All right, let's figure out what my errors are before I go too much further. All right, so where are they? Okay, right here. All right, so here I have a little error. It says type mismatch. Oh, I see. So I declared X here as a double. Oops. We're counting with it, right? So it should be an integer. All right, simple enough fix. Control S to save. Let's try that again. You guys catch that? Okay, good. All right, so here we have our prompt. So enter a numeric value or 999 to quit, and I'm just gonna be bold and quit right away. So I just, I want you to notice too that, okay, not only did it quit, but it figured out that I hadn't entered any numbers and it gave me the error. And in fact, I probably should say something else like program is over or goodbye or something like that. That's not a very great user message. Let's try it again. This time, let's actually enter in some numbers. And so I'll enter in 1, 2, 3, and I'm doing this on purpose, entering a sequence of numbers, easy to keep track of it. I'm only going to enter 7, and you know what? I'm done. All right. And so the output then becomes, let me get my mouse here. You can see the complete output, or close to it. So once I hit that 999 to quit, it stepped out of the loop. It performed the calculations, 7 numbers, and their average is 4.0. Now, if I add all these together, is that true? Let's see, 13, 18, 22, 25, 27, 28. 28 divided by 7 is indeed 4. So that is truly the average. And then it shows here the difference. So is 3, is 1 3 away from 4? It sure is, in the negative direction. Is 7 3 away from 4? Yes, it is, but in a positive direction. So it seems to be working well. Now, the one other thing that you should try here is try exceeding the bounds of the array. So in this case, I'm going to keep entering in sequence the numbers because it just makes it easier to do. So there's 15. And see, I didn't even get a chance to enter another. It automatically plowed through. All right. And I did use these numbers intentionally because, first of all, I know the math on it is clean. It's also really easy to keep track of what you're entering. But hypothetically, you can enter any floating point value here and it will work, positive or negative. All right, for those of you that are watching at home, this video, I'm just going to kind of review the code here really quick. So this is the top half of the code up through line 23. And this is the bottom half of the code from lines 19 through 40. All right, we're taking a pause here in class. We're going to take a break, and we will be back to work on the next exercise shortly. Okay, we are back from break, and we are working on exercise number 6, which has 2 parts. And it looks like we need to create a total of 3 files here. So let's see how this goes. Excuse me. Create a class named salesperson. Data fields for salesperson include an integer ID number and a double annual sales amount. Methods include a constructor that requires values for both data fields, as well as get and set methods for each of the data fields. Write an application named demo salesperson that declares an array of 10 salesperson objects and set each ID number to 999 and each sales value to 0. Display the 10 salesperson objects. So they have a very specific thing they want us to do here. So let's start out with creating the class file for salesperson. That should go pretty quick, I think. So let's see how we would do that. I'm going to come down here and I'm going to create a new class file. And we are going to call that salesperson. And I forget if I'm camel casing this or not. It doesn't look like I am. And no public static void main on this because this is a class file. All right. Let me zoom back in a little bit. I zoomed out a couple of clicks to get all the code on the screen from before. So in this one, it had a very specific thing we needed to do, and that was create these 2 data fields. And so we can start with the first one, I think was an ID. That one makes sense to be an integer, just a string of numbers. And then we also were asked to create one that stands for sales amounts. And usually when we're doing, monetary things, it's good to do it with a double, and we'll just call that sales. All right. They also said that we should have a constructor function, and then getters and setters for everything. The constructor is really pretty simple too. We're just going to reiterate the name here. And find a way to feed the values. And so we do need to feed in the ID number, and you can see how I'm naming these differently, and then the amount of the sales. Inside the constructor method here, we're just simply going to assign the values to the actual object data fields. So we're going to take the ID num that comes in and assign it to ID, and then we're going to take the amount that comes in and assign it to sales. And yes, I am noticing the typo in the first line, just in case you're about to correct me. That should be capitals here. And you know what? Maybe it's better to just do this lowercase. I'll do it lowercase because remember the convention is all uppercase is a constant, and we don't want to do that. All right, so this is our constructor. I also said we need getters and setters for everything, and if you guys remember, the easy way to do that in Eclipse, by the way, is just to right-click. I'm trying to remember what menu it's under in this program. I was just doing the same thing, ironically, in Java 2 with NetBeans, and I forgot how to do it in NetBeans altogether. And I'm trying to remember how to do it here now. Does anybody want to give me?
Source.
Thank you. Generate getters and setters. I want you also to notice that there is also a thing that generates constructors using fields, and I didn't have to type the constructor manually at all. I could have just clicked this. But we're going to generate getters and setters. Do we want to do it for both? Yeah, we sure do. So we'll just check both boxes. And we'll say OK. And then you'll see here at the bottom, they move their constructor to the bottom. I'm not really a fan of having my constructor at the bottom, I'll be real frank. And so what I'm going to do here is move that back up to the top. So it looks like, okay, so I see what it did. It just generated everything in place from where I was at, right? That's where my cursor was, so that's where I put it. So let's redo that. So let's right click, go to source, and getters and setters. All right, check both and say okay. And now we have all of our getters and setters. So each one of the fields, ID and sales, has a get, which returns the value back to the program, and a set, which allows us to change the value if we want. Same thing for sales. One returns it, and one allows us to set it. Okay, so now that that piece is done, we can save. We don't have any underlines or highlights or anything, so we know our code is valid. Now we need to create the demo program to test all of this. Now, they gave us very, very specific instructions on how to do this, but one of the first things was kind of an interesting thing. First, let's create that class file. So we're going to create a brand new class file here, and this one we will call demo salesperson. This will have an executable component to it. So we do want to click the public static void main on this one and click finish. All right. The next thing that we'll want to do is, and this is where the instructions are interesting, so I'm going to reread them for you just for a moment here. Write an application named demo salesperson that declares an array of 10 salesperson objects. Now, this is where we are kind of doing a completely new thing, and conceptually, it's a little bit of a mind blower because this is what's happening here, folks. We are going to take the class file that we just created, the salesperson Java file, which in itself already has 2 data fields within it. And we are going to create an array of these objects. So these objects, instead of being a single number going into the array, we are putting an entire object, basically this whole class structure is going into each position with unique entries for each thing. Well, not initially, but eventually. And that's kind of a neat thought here. So wait, I can create an array, not of type integer, not of type string, but of type salesperson. Yeah, you can totally do that. And keeping in mind that each array position is storing the complete object with all of its capabilities, all its methods, all its private variables, any attribute that you set for it that makes it unique is all stored inside there. All right, so how do we do that? Well, first of all, we'll call in salesperson as a class and put in the square brackets to indicate that we want an array of it, and then we will name it. And what I did last time is I called it sales people, right? Which makes sense if you have a bunch of salespersons. That doesn't make sense though. And we will pre-declare a size because we were told to. And so we're going to pre-declare it to a size of 10. So now we have 10 sales salesperson objects. And yeah, that's why it's highlighting, because this name here has to match this one here. And
Just forget, yep, the S.
yeah. You know, Larry, if it's not one thing, it's another. But you know what? That's why the highlighting is so handy in this product, and why I encourage people to move away from JGrasp as possible, typically. Another thing I'm going to throw in here is just a counter variable. You know what? I could do it here. You know, and I'm thinking, why am I doing this when I can just do it right in the loop? So that's what I'm going to do. So they did ask me to pre-populate 10 of these with a preset ID value and a preset sales value. The preset ID is all 99999, and the preset sales value is 0. So we're just building out the salespeople, but giving them kind of dummy values to start with. The loop that I have here created to do that is this one. And I'm just going to paste this in, folks, for speed and efficiency. So I have this for loop set up, and I do have to declare the int of I. This loop will start at the position 0. We'll count up to the salespeople length. Notice a less than sign here, so we'll never reach that last position or last number. And then we'll increment once through the loop. Every time we loop through, we're going to take the current position in our salesperson object array and feed in through the constructor. That's why we're doing new salesperson. That's the constructor function. And we're presetting these values so that constructor function does require an ID and a sales amount. Then, well, we better make sure it's working. And what will happen in this situation is I will paste in another command, another for loop, whose job it is to traverse the structure and then output this. So, you know, the anatomy of how this reads. Once again, we have a loop here, and I'm taking a look at my int I here. So let's start int there. Sorry about that. And once again, we're going to traverse the whole structure. And then for each salesperson, we are going to output their ID and their sales amount to make sure that all the values arrived. And so it'll be a listing of 99999 and then 0 is what it's going to be, but 10 times over. All right. That's the entirety of this program. There's nothing more to it. And I know that some of you are like hurriedly copying my code as you watch, which is fine. So I'm just going to come down here, leave this active up here, and just run this in the background. Let's do a Control S to save first. And let's hit that run button. And then you will see the output here. So salesperson 0, the first one, has an ID of 999 and annual sales of 0. So we basically created 10 dummy salesperson objects with preset values as we were instructed to do. So we just set it up basically in memory, and there's nothing going on here yet, but eventually we will change these. All right, so let's consider part 1 or 6A complete. Now we need to move on to the second piece.
Sure thing. So what's starting to be for a loop on here is the fact that we have new salesperson in 2 different locations. And I know you have to do it that way because when I tried one without, it didn't work.
Right. Okay, so let's explain what's happening. And that's an excellent question. And I'm actually very glad that you brought it up because it saves me having to loop back to it to explain. In this first line here, we're setting up an array that's going to hold, think of it as a collection of salesperson objects. And in order to instantiate the array portion of it, you know, this part of it, you know, the square bracket part of it, you need to do this new declaration to set the size. So this does not refer to an individual salesperson, but rather to the array that's going to hold them. And
okay.
Yeah, so what we're really saying is this is the data type that's going into the array, which just happens to be a salesperson object. On line 7, conversely, this is actually calling this constructor function here and building the object. That's the distinct difference. But an excellent question. Absolutely.
So they're not objects. They're just an empty list at the beginning.
Well, you know what? you're right. This is an empty list to begin with, but the data type that it's capable of holding is of the salesperson object.
So you can't call the getter and setters,
Not from here.
not from that point.
No. But once you have the individual salespeople created in this step, then you can call the getters and setters
Okay.
in the aftermath of that statement. Yeah, that's a really good distinction, and thank you both for asking that question. All right, let's read the next part of the exercise now and see what they have us do next. So the next part of it says, modify the demo salesperson application so each salesperson has a successive ID number from 111 through 120 and a sales value that ranges from 25 to 70,000, increasing by 5,000 for each successive salesperson. Now, I'm hoping you guys hear in the terminology there. I mean, you can do this with a loop, or you can do this manually, by the way. But you know, in the grand goal of things, I think they're trying to push you to do a loop approach on it. So the first thing I'm going to do is I'm going to go ahead and just create a new file here, and it's going to be demo salesperson 2, I think is what they want us to do. And I'm not going to worry about the public static void main thing right now, because what I'm going to do is I'm going to come back to the first one and copy all my code, because it's silly to recreate it all. And actually, I'm going to copy just the main method here and then make my adjustments. Let's paste that in. All right, so now we can do a little bit of tweaking here. And do we still need to create the array of salesperson? Yes, we do need to do that. That's going to stay. The other thing that I'm starting to think to myself is the stuff that we did here, you know, inside of these loops is definitely going to change. Will this second loop change though? Can I just leave this one alone? And I'm actually kind of asking the question and thinking about it at the same time as I'm looking at my solution file here. But we still need to display what's in there. So the second for loop is fine, right? We really, in essence, are going to have to rewrite the first for loop so that it accomplishes a different set of tasks. So we have to tweak it. And we might also want to start thinking about a few variables that might help us in the process of all of this. And so the first thing I'm going to do is I'm going to think about this in a couple of different ways. First, I'm going to think that if we're assigning a value, and then we're, you know, both for ID numbers and for sales, that we're going to have a starting value, and then we were given an algorithm for increasing each of those over a range. And for me, it makes sense that I start with putting those values into variables and then building from there. So I'm going to begin by just saying int assign ID, and the first ID they want us to use is 111. So I'm just going to preset it. The other thing they asked us to do is to assign the sales. So once again, I'm going to do this with an integer. Yeah, you could do it with a double, whatever. It doesn't really matter. Why doesn't it matter? Because once we send it off to the class, it will cast. It will cast to the different value. And we'll set this to 25,000. Right? And then the other piece, and this is the part where you might not want to hard code it. Some of you won't even think about it, and others will. But that increase amount of the sales is something that we can hard code. And so let's say we wanted the sales increase to be 10,000 instead of 5,000. We could hard code that here. And I didn't mean to type in, I meant to type int. And so I'm just going to create a constant called sales increase, where that value can be hard coded. And that way, if I wanted to tweak this and say, oh, it's a $10,000 increase each time, we can just change that one number and the whole thing will fix. All right, so that's our initial variable setup here. Now we need to start thinking about this loop here and how we're going to change it. So the first thing I'm going to do is think in my head. I still have to traverse the same structure. There's still the same number of salespeople. Will this for statement here on line 10, what's inside the parens, will this work? And I'm thinking, yeah, why wouldn't it? Right? We're still working with the same size structure. So this part of the declaration is fine, right? Where we need to change things is on the inside. And in fact, what's happening here, where we're assigning to the current sales people, the instantiation of what we created, these values based upon what was hard coded before. Now this part needs to be the part that changes. So we're not going to send hard coded values in. We are going to send in these two things, which yes, start hard coded, but will increase each time through. So we're going to replace the 999 with this variable name for the ID, and we're going to replace the 0 with this variable name for the sales amount. All right. So the first time through, it will take the first person and set it correctly to 111 for ID, 25,000 for sales. Beautiful. But what do we have to do in the aftermath? Well, the one thing we have to do is we do have to increment the ID number. So we could say assign ID plus plus. And if you want to goof around with this, I'm looking at my old example on this. I did plus plus because I get people ask, why do you do plus plus before or plus plus after, and why do both work? Well, it's relative to when you do it in memory is really kind of the thing. In this case, it wouldn't matter if I did it before or after because it's happening after the statement where it's relevant, but it can change the output depending on where you put it. I'm doing a plus plus this time just to show that you can do it. Right. With the sales figure, we're going to add a line here, and here we're going to say assign sales. So the amount that we're working with is going to increase each time. And how much is it increasing by? Why don't we do the plus equals thing? This is much easier than writing out the whole equation. Every time it's going to go up by the sales increase amount. So every time it loops through, it'll grab the value, whatever assign ID and assign sales are set to, will populate that. It starts out with 111 and 25,000. Then we increment the ID, so it'll be 112 the next time through. And we're incrementing the sales amount by 5,000, which is a predetermined amount. So the next one will be 112 and 30,000. And it'll keep going until it goes all the way through the array structure. And then we will print out the result. So believe it or not, folks, close to done here. All right. So let's check it out. Let's run this and see if it actually works. All right. Control S to save. And we're hitting the run button. No red flags or errors or anything. Let's bring up the console here. And notice it just did it. All right. And notice it also failed. And I have to think back now to my code. What have I done that it's failed? And I know exactly what I did where it failed, because I didn't look at the output loop, did I? Right? I just assumed my output loop was correct because the first line of it was correct. But clearly, I mean, part of the code worked, right? The 111 got in there and the 25 grand got in there, but it's certainly not showing 112, 113, et cetera, and 25, 30, 35, 40, et cetera. That's what it should show, right? So now let's go back and take a look and see why. And what I'm hoping is that we can put our heads together collectively, and you guys can maybe tell me why it didn't work rather than me telling you why it didn't work. What did I do wrong here where it's not working?
Is it because of the curly braces are missing?
It is. Where is it missing? And Dennis, you caught it.
On both of them.
Yeah, on both of them. It really is missing on both of them. But what a lot of people miss on this one, this is actually one concise statement. So it really is one line of code. So I really don't need the curly brackets. But yeah, you guys know my general rule of thumb is open and close your curly brackets and then put your stuff inside, even if it's only one line of code. Because case in point, here's a scenario where we failed because we didn't pay attention to that. And notice the compiler said, that's fine, right? Because there's no syntax errors. It was a logic error, not a syntax error. All right, so now all of these statements are bundled together. So what was happening is it did loop through here and do this 10 times, and then it incremented this by 1, incremented the sales, but it wasn't part of the loop. Okay, so now it should work. Control S to save, and we're running it. And take a look at that output. Okay, incrementing by 1 each time, all the way up to 120. Incrementing by 5,000 each time, all the way up to $70,000. Are these outputs correct? Absolutely, they are correct. All right, a little bit of trial and error there, but once again, I think of some pretty valuable stuff to learn here overall. So those of you watching the video and copying code, here you go, this is a complete program. All right, folks, that kind of wraps it up for tonight. Just to kind of review this exercise really quickly, here's the salesperson Java file. I'm going to see if I can zoom out here, get it all on the screen at the same time. So that's our class file. Here is demo salesperson, complete program. And then finally, demo salesperson 2, the complete program. That wraps it for tonight. We'll see you all next week. Take care.